Hello, everybody. So today I did the dietary supplements for building up muscles from Khan Academy's Biological and Biochemical Foundations of Living Systems passages. So when I first approached this, I didn't really know what dietary supplements for building up muscles would be about. Content-wise, I thought maybe it's going to have something to do with metabolism, but as I read into it, it had much more to do with specific biochemical pathways. Also a thing, just general knowledge of how could a biochemical pathway work. It's important for the MCAT. So the first question: what is the PI or isoelectric point of isoleucine, leucine, and valine? I did not read any of the passage up to this point. I just jumped down to this question, and sure enough, this question could be easily answered without even reading the passage. If you go up to Figure 1, where they show branched chain amino acid properties, they give you the pKa of the amino and carboxyl groups. And what I did here was something exactly what the MCAT would want you to do. I saw different numbers that showed a distinct pattern if I knew that you add pKa of the amino and pKa of the carboxyl, divide them by 2, there's your PI. So if you add these pKa's, you're going to end up seeing that isoleucine's total sum is going to be higher than leucine's sum, which is going to be higher than valine's sum. So just adding the two pKa's together, you're going to see that the pattern is isoleucine is the biggest, leucine is the second, and valine is the smallest. So when I look down at, once again, they want the pattern isoleucine, leucine, valine, so it should be largest to smallest. And when you look down here, sure enough, there's only one answer where it goes from largest to smallest, which is 6.04, 6.03, 6.02. I don't even have to do the problem, click check, and it's correct. So remember those formulas. They could really help you out. All right, question number 2. Which of the following amino acid substitutions would likely be the least disruptive to protein functionality? So here they want you to know about the chemistry behind amino acids, and it was pretty apparent that if you go from valine to alanine, you're just shifting around some methyl groups. They're both really small nonpolar amino acids. Therefore, that would be the obvious answer, and it was correct. Question number 3. In Figure 2, which mouse had a higher level of mTOR basal activity? So they said basal activity here. They gave you the figure with all the different amino acids and how they affect things. But when they say basal activity, they're looking for the control, and they showed us that the control is in blue. So that would leave mouse 2 as the one with the higher basal activity, just by looking at the graph. Okay, in Figure number 2, which branched chain amino acid increases the activity of mTOR? This one was tough, and it almost got me, but I caught what they were doing. So obviously what you're looking for here is which amino acids cause the highest peak on this bar, the tallest bar on the graph. When you look at mouse 1, it's clear that leucine increases activity the most. Then when you look at mouse 2, you see a tie between leucine and isoleucine. My thinking here was, so how can you say for sure which one branched chain amino acid increases the activity? They give you one of the answers as none of them, but that's not true, because it looks like leucine and isoleucine do. However, I think what they tried to do, if you look at the error bar on isoleucine on mouse 2, it goes below mouse 1. Hang on, that doesn't make any sense. I want to look at this hint, people. Okay, so number 1, the activity of mTOR is measured. If I got this right and I just did it like by accident, I apologize. But that was what made sense in my head. Okay, so the first hint. The activity of mTOR is measured by the phosphorylation levels of EIF, blah, blah, blah. That's true. That's what they told us. The increase or decrease of mTOR activity can be determined by comparing phosphorylation levels of that thing in control with the other samples with added amino acids. Okay, what's the third one? Leucine is the only amino acid that increases phosphorylation levels within the margin of error. Okay, awesome. Yeah, so it was those error bars. That was the reason for choosing leucine in this case. All right, and question number 5. If nutritional companies are using the data presented in Figure 2 as a reason to take supplements, which of the following assumptions are they making? So I got this one wrong the first time. So we'll go through these one by one. So any increase in the EIF4EBP1 phosphorylation is due to the mTOR pathway. Yeah, they would be assuming that. That's what I came out of it with. They talk about the use of EIF4EBP1 and how it does, or does it increase the mTOR pathway? No, mTOR pathway results in the phosphorylation. Okay, so any increase in that is due to the mTOR pathway. Sorry, I got mixed up in my head. So mTOR increases that, but who knows, maybe something else also increases the EIF phosphorylation pathway. So that would be an assumption that they were making. Okay, number 2, the branched chain amino acids are only activating the mTOR pathway. That one just didn't make sense to me. It does say recently studies have suggested that certain branched chain amino acids are more effective than others in activating mTOR, suggesting that nutritional supplements could be more effectively targeted towards building muscle through this pathway. But that didn't really strike me at first, so I didn't put it. I'm pretty sure that was one of the right answers, though. And then 3, increases in EIF phosphorylation lead to increased protein levels. I didn't think that was an assumption, because up here they were talking about how they know what the function of this EIF protein is, and they said it's a translation initiation protein. It sequesters a different translation initiation protein. Oh, hold on, blah, blah, blah. It brings mRNA to the transcript and the ribosome. It causes the initiation of translation. They kept saying things like that, and I thought, okay, so they're making proteins. So I thought that was like known science or something like that. But I guess they didn't technically say that. Well, but that's what I thought the assumption was, right? That it was leading to more increased protein levels. However, I was mistaken. No, I wasn't. Wait, I got it all backwards. I'm doing this on fly, people. This is professional podcasting here. So the answer was that the assumptions that they're making are that EIF phosphorylation leads to increased protein levels, and that EIF phosphorylation is due to the mTOR pathway. The branched chain amino acids only activating the mTOR pathway, I don't totally understand, but that's Khan Academy for you. So let's look at the hint. Figure 2 is based on the assumption that increases in mTOR activity result in increased muscle mass. Okay, so yeah, that makes sense on Figure 2. As long as the branched chain amino acid activation of the mTOR pathway leads to EIF phosphorylation in this experiment, it doesn't matter what else the branched chain amino acids act on. As long as the activation leads to phosphorylation, it doesn't matter what else they act on. Right. For their purposes, at least. Right? I think so. Okay, the nutritional companies are assuming that any increase in EIF phosphorylation levels is due to the activation of the mTOR pathway by branched chain amino acids. What? And then that this in turn leads to increased protein levels. The nutritional companies are assuming that any increase in EIF phosphorylation levels is due to the activation of the mTOR pathway by branched chain amino acids. They just said assumption is number 2. Which of the following assumptions are they making? I don't understand this, people. Tweet at me at the Twitter I don't have if you have any ideas.